Well, hello everybody, it's Chaz Large here with another Fix It video for you, and on the bench today we have been sent a Philips mini boom box. It's an AZ1003 CD sound machine, would you believe, and it's got a CD player in the top, and it's got a FM and medium wave radio. There's a tuning dial on the side there. And it's also got a cassette tape player in the front there as well. So the complaint is that it does not play CDs. So let's plug it in and give it a bit of a test and see what happens. Let's just try off-the-shelf CD, KT Mellower, and see what happens when we pop that in. So we better turn it on to CD, and let's go to the overhead camera and see if we can see. So we just got two dots. Let's go play, stop. Doesn't appear to be doing anything, so let's open it up. Now there's usually a little button of some kind. I guess it's probably part of the lid mechanism in there that closes, that tells you that the CD is playing. Of course, with a solid lid we can't see what's happening, so let's have a little look, see if there's a lever or a switch. Yeah, there's a little switch in there which you probably can't see, but just in there's a little tiny switch which is activated by the door closing. Now I can hear the optical block trying to focus, so let's take the disc out. Let's pop the camera in there and give it a quick tweak for focus. Okay, so let's just try. Sure enough, the lens is popping up and down. Now, if I can get as near above it as I can, let's have a look and see if there's any light. Switch to can't see any light at all. So what we need to do is to check to see whether the there is any kind of laser light coming from it. So what we're going to use is a laser power meter, which tells us whether we've got any laser light coming out of it. Take the little sleeve off which covers it up. And my screwdriver again. Find that little switch again. Right, we've got the meter set to 0.3. If I move the camera over there so you can see it, and very little laser light coming out of there, less than 0.1 milliwatt of laser. Yeah, so that should be, that'd be 0.3, that 0.2. Yeah, there we are, it's less than 0.1. So I would guess that probably, and move the sensor around a bit, no, that's still definitely less than 0.1, 0.05, 0.02 milliwatts. So that I would suspect is pointing to a faulty optical block. So we'll pop that to one side. Now sometimes we might be lucky in that the problem is to do with dust in the optics. So what I tend to do is use an aero duster, very gently blowing into the optical block and into here, just a short little burst of aero duster and around the optical block, because being a top loader, dust can settle down not just on the objective lens but also on the optical bits and pieces underneath, and then also just a little brush off of the optical block with a dry chamois cleaner, and then we'll give it another try, see if we get any more output. To be honest, I don't think we're going to. No, exactly the same. So I would say probably the optical block has had it. We would probably need to replace that, but it could be electrical in terms of the voltage getting to the it could be the actual electronics supplying the power to the optical block. Unusual for it to go low power in terms of electrical problem, but it could be an internal supply which has gone down. So we'll have a look inside and see if we can do that. Before we do that, just want to quickly test the cassette deck. Okay, so let's eject that. I'll have a little look, and so it goes in that way, and we'll put it onto tape. Tape and power off is one and the same. So tape seems to be working, so in terms of some of the internal power supplies must be working, and also we heard the radio working. Radio reception in here isn't the best. Yep. So I would guess probably all the internal power supplies on this device are actually okay. So it's still very much in the air as to what the problem is with the CD, whether it's the optical block. But we will take it apart and we'll give the optical block another bit of a clean out internally and see if that leads us to anything. So let's have a look and see how we take this beastie apart. Let's put that camera a bit further up and switch over to it so we can see what we've got to do. So taking this apart, now one thing I did notice inside the lid there is an awful lot of Chinese writing. Presumably it says the same, do not touch the lens, in Chinese. I'm guessing that this is not a Netherlands Philips, this is a Chinese Philips. Let's just have a little look at the back. Designed by Philips Europe, made in China. There we go. So it's made in China. So consequently it won't be up to the standard high quality that we would normally expect from Philips. Anyway, there we go. So now looking at this, one of the screws on here is partially unscrewed, so I guess somebody's been in this before. Right, and the screws out, the back section seems to come away quite easily. And we've got a power connector here which we should be able to remove, and an antenna connection which we remove, so that removes the power section. That then gives us access to the CD mechanism and the two little speakers in the front. To be honest, I'm not that impressed. It doesn't look anything like as good a nice piece of Philips equipment as I've seen in the past. The chips are made by Samsung, so it's all probably just all been bought in and rebadged as Philips. And there's a little switch that I was pressing with my screwdriver there. A little switch, so as you open and close the lid, so that little switch was closing it, saying disc has been inserted, activate, and that goes onto this little button here, this little contact there. Right, can we get at the optical block in any easier way? We can, sort of. I would guess really and truly it's not going to be easy to get at and do anything with. Now we can manually bring the sled, the drive sled, further up here. In fact, it will probably run if we just pull it like that. So there we can see get the light right. Might have to bring a little bit of extra light in there. This might flicker. There we can actually see the optical block, and that there is the I would guess the pickup diode, because there's 8 connections for it. So we've got like a set of diodes which pick up the light from the laser. So the laser is probably mounted on this little circuit board down here. So it goes across, goes through a prism, up through the optics, back through a dichroic mirror, and down into the pickup lens assembly there. So really and truly what we want to do is to take this whole mechanism out and see if we can have a little look in there and see if there's any dust we may be able to clean off, because it may not be a faulty laser. It may just be that the optical path is obscured by dust. That is quite a well-known issue. Let's just take the brightness up a little bit, because the camera isn't showing things as well as it can be. So basically I think what we need to do is to take off this top circuit board here, disconnect the ribbon, disconnect the motors connections here, and we should be able to remove the circuit board out, and then we should be able to drop the optical block out. So let's just take this circuit board off to start with. gently ease out this ribbon cable from the edge connector. Maybe from the main circuit board might be easier. Either way, it's proving to be quite tight in there. There we go. Usually they come out quite well. And then we should be able to pull out the connector. For the motors. And then we've got another circuit board edge connector there which I can just grip hold of. And that one there, the switch. Like so. So we can move the circuit board out of the way, and we can now get at the whole optical block. Let's focus that again for you. So we've got 4 screws holding the optical block in. With rubber feet, so when it's the right way up, the rubber sits on the bottom edge of that screw there, so it supports the mechanism. That should release the whole optical mechanism. There we go. Let's put the main unit to one side. Okay, so just looking at this, the optical block appears to be fairly well sealed in here. So there you can see the actual legs in there. That's the legs of the laser diode, usually 3. Okay, one is the diode, one is power, and one is a sensor. And that's the pickup diode which is there. I don't think taking this top cover off here is going to help in any way in terms of seeing what's in the optical block. Maybe. Well, let's take that out anyway. Let's take that out. That's be 2 screws. And 2 clips either side. There we go. Okay. Right. Okay, there's no type number on the optical block, which is a little bit concerning. Ah, there we are. It's a Sanyo. There it is. It's a Sanyo. Can't quite fully see it with my eyes. Let's put the old inspection specs on and see what we can see. Right, it's a Sanyo SF SF-P101N. Right, let's get my little notebook. Okay, let's just have a little look on the internet and see if they are readily available as a spare part. It might be worth just seeing what they cost to obtain as a replacement. Right, on here we've got a replacement optical block, Sanyo SF-P101N 15-pin laser for £12 with £5.40 shipping, which is a reasonable supply, but it's coming from outside the UK, so that's going to come from China. Let's also have a look at AliExpress, which is offering the same optical block, and it looks identical. It looks very similar to the one that we've got in there. If we quickly go back to the overhead camera, you can see it's very much the same, and that's £4.38 with free shipping. Well, for something this old, it's probably worth having one of those as a direct replacement. So the only other thing I think we can try, and that is to see if we can blow a little bit more dust inside it, but I don't know whether we can actually get anything better in there. In fact, actually the optical block is remarkably sealed. A lot of these that I've worked on over the years, all of this area is all pretty much open to the elements and can get dust in it, so this one looks a lot better sealed. Now, tempted as I am to undo these screws and take this out, there's seals here which would basically mean the alignment of this pickup diode to the rest of the optical block would be critically endangered. So to be honest, I don't think I'm going to bother with that. I think I'm just going to order a replacement optical block, and we'll replace that and see how we go. I mean, for £4 and a couple of weeks wait of shipping, I think that's a pretty much an easy to go down route to fix it, and I'm pretty sure the customer will be happy to pay that. So I'll be back after I've got the replacement optical block, and we'll put it in and see how we get on. Right, we're back with this Philips Boom Box, and we've been a couple of weeks, probably about 4 weeks altogether, sourcing a optical block for this. Now let's just show you on the overhead camera. What we have here on the original optical block here is the optical block. We know we've tested this and found that it's being low output, and if we look on the side of this, and if I zoom into this, hopefully you will see that there is a part number printed on the side which says SF-P101N, which is the original Sanyo part number. And you can search for this and find plenty of these available on eBay and other suppliers, and you can go ahead and order it, and that's exactly what I did. Ordered one of these, and although it doesn't actually say the part number on there, it says it there, sort of, you can see underneath it, SF-P101-P, and you go to fit it, and you realise that before you even fit it, that the layout of the optical block is just slightly different. The control resistor that changes the value of the laser output is on the other side. It's down here on the original one, and to all intents and purposes it looks the same. And if you go and plug in the connector, it will plug in but it won't work. You won't get any laser light out of it. And the reason being is that there is two versions. If I hold these together, you should be able to see that there's more pins on this one, the new one, than there is on the old one. Okay, if I line them together there, you can actually see that there's one more pin. So this one is a 16 pin connector and this one is a 15 pin connector. And if you look at the wiring on the circuit board, you'll find that the wiring goes to different places on different parts of the components. So this is never going to work in place of this. The problem is that you have to say specifically when you're ordering that it's a 15 pin connector one that you want, not a 16 pin, which is what I bought. Which is why I've written on the box, for future reference, should I ever get one, that it's a 16 pin connector. Took a little while finding, but I did find one, and a UK supplier, because I needed it fairly quickly. So there we have an SF-P101 15P. 15 pin. So what we're going to do is we're going to fit this one, and hopefully that will resolve our issue. And if we actually compare it side by side, there's the original one. You can tell because I've written a little black 0 on there to say original, and the layout of the board is identical. The pin connector is identical, so this should in theory work. So let's put the original one down there, put that back in that little box. Let's go ahead and fit this. Now we've got the little shorting link still in place here to protect the laser, so we'll leave that as long as possible before we actually take that off, so as any static that may be around affecting it. And also we've got the lens cover. We may have to take that off to actually get the thing into the mechanics. So these are the mechanics, and because I had to put this to one side while I was waiting for other things, I had to put it all back together. So let's just release these little locking screws, slide out the slider bar, and we should now be able to get the optical block to go in to the mechanism. Yeah, I'm going to have to take that little cover off to get that in. So it has to go in sort of like slightly at an angle to get that. I mean, you could take the gear wheel off, but if you get it just right, if you just get it at an angle correctly, you should be able to just drop it in, which is the way the old one came out, and it should twist into that little slot. There we are, there we go. Just crank it along a little bit like so, leave it at that position, slide the slide bar all the way through, make sure it engages with the, and drops down into that little between those two little lugs, and tighten it up. So that should now slide along there, and just to ensure that it slides nice and smoothly, just apply a little bit of moly slip grease, just a tiny little fraction on there, onto the bar, on the top because it's resting on the top. And then run that backwards and forwards a couple of times, and that should be a nice smooth travel. And then if you've got a little bit left over, just run it on that little edge of the metalwork there as well. Again, just ensures a nice smooth movement, but it's controlled by the motor, so there's no stiffness there, so it just stops it sticking, as it were. It just helps it to slide along. Okay, now we put the top cover plate over the top and gently pop that into position. Engage the little lugs into the holes where they go. One goes on the side, one goes in that little hole at the end there. There we are. And then we pop the single little screw that we had left for that one. There should be two screws. Where's the other one gone? There it is. So we've now refitted that, so we should now be in a position to put that back into the whole chassis. Let's zoom out a bit so you can see exactly what we're up to. Thankfully I had a bit of space. I could leave it in a partially disassembled position, so I didn't have to screw it all back together backwards and forwards to do that. So we should now be able to pop the optical block into position. Right, so we fitted the mechanism back in, and we just got to screw the mechanism back into place. That's the 4 screws with the washers on the top. Okay, now we're just, before we put the ribbon and cable and so on back on, we'll just remove the solder blob on here. So we've got anti-static on, just a little bit of desolder braid onto there, and the blob is gone. So now we can put the circuit board back, push that right the way home, plug in the ribbon cable nice and carefully into the optical block, screw the rest of the chassis screws in, coupling for now just to hold it in place while we put the other plugs in. So we've got one ribbon plug plugs into here. Tilt it up that way. We've got the one that plugs into the mechanism for the motor drive. Sure that's nice and done, and then this one, which is the lid switch, plugs into there. So that theoretically should be a now working CD player. Okay, remove the back panel because that's where our power comes from. It plugs into here. Remove our anti-static strap for now. Plug in our mains. Open the lid. Let's just see if we hear from Miss Katie Miller. We hear a disc spinning up. 12 tracks. Track 1. Yay!
They say the world might.
Right, so that seems to be fixed. We have replaced the optical block, which has fixed it. Just out of interest though, I think what we'll do is we'll just see what kind of laser power there should be. If you're fortunate enough to have a laser power meter like I have, we should be able to see what laser power this little device generates. We've not adjusted anything, we've not tweaked anything. All we've done is quite literally replace the optical block. So the little switch which I can see is there. So if I put the laser light roughly the same height as the turntable and press the little switch, look at that. We're on 0.3 milliwatt range, which is the bottom range. So that's 0.1 of a milliwatt, which is a lot more if I move them out the sensor around. Yeah, that's a typical 0.1, yeah, of a milliwatt is typical laser power for a good working CD player. So, a successful repair. Although it's taken quite a while to get there because we didn't get the right optical block to start with. So it's always worth taking a closer look, as I obviously didn't, at the connector. The layout was obviously significant in the way it was because of the 15-pin connection, and that's what we want, is a 15-pin optical block, but the most prevalent one seems to be the 16-pin, because although I ordered another one which said 16 pin, you could sort of see on the diagram that it showed like it was a 15-pin. When I got it, it was actually a 16-pin, same as anything. You have to find one that specifically states that it's a 15-pin connector that you want, and that's the one to use. So we now have a faulty optical block, but it does work a little bit, so I'm going to hang on to that as a sort of a test optical block, so that if I get another unit in with a 15-pin that's giving absolutely no output at all, I can pop that in place of it very quickly just by connecting the ribbon cable. If I get output, I know that the rest of the circuitry is working, it's definitely the optical block. But if I don't get anything, then at least I can sort of say, well, probably it's not the optical block, it might be the electronics feeding up to it. So it's useful to hang on to old spare parts sometimes for that purpose if you've got some kind of output from it. So anyway, there we are. That's our repair. I will now finish off putting it all back together and putting the screws in and tidying it all up, but you don't need to see that. So thanks very much for watching. Hope you've enjoyed this video, and I'll be back with more as soon as I can get something more interesting for you. There's so much run-of-the-mill that you get that is just too much to video all the time and put these on. So you know, it's the interesting ones I hope you're interested in. Do let me know what you think of the video in the comments. Send us an email. There's a contact on the main page if you want to send us an email. But always happy to help with any help and advice I can. Cheerio now. Thanks again for watching.